Star Trek? Did they go to Rigel, Rigel 4, Rigel 5, Rigel 12? I think the one episode was Rigel 12, right? Rigel is the last star in the sky. It's going to have a planet with life. And the reason is they simply don't, some stars don't live long enough. Our life on this planet goes back about 3.8 billion years. The planet is 4.6 billion years old. So it took 800,000 years, or 800 million years for life to form. Big stars like Rigel live 100 million years tops, maybe 10 million years. Live short, live fast, die young, leave a good-looking black hole. So I had postulated to Bradley, I did my presentation, my star presentation, and we talked about these various things, and I said, what if there's a star that's bigger than ours? So our star isn't big enough to explode. Our star will never supernova. But what if there's a star that's just bigger than ours? And the bigger they are, the shorter the lifetime. I said, what if it lives long enough for life just to have formed that first cyanobacteria, the first blue-green algae? What if they have that just forms life like this? They're called stromatolites. They're still alive today, but this is the first life form on Earth. What if the life just says, we're here, bang? How many times did that happen in the galaxy? And that conjecture became Eye of Jupiter and Rapture. They said, cool idea. Let's put this planet, let's collect algae, which we're going to be eating for the rest of the series, and then blow it up. And that actually became one of our signs and portents on the way to Earth. And we also linked that to the mandala, which, by the way, got linked to something else. In season 4, Bradley Thompson and I and Richard Hash were doing an interview with military.com. It was a popular podcast. And Bradley said, we'll come up with something outlandish thing. We're looking for Earth. We need a landmark we need to get to. It's got to be able to be one thing from one side and one thing from another. You got to be able to see it from a long distance. He said, Kevin gives me something, and I run to the writer's room, and I'm a hero! And so that's what Bradley said on the podcast. And again, Saturn had a big influence on season 4, and in the end, you can't really tell. This is something to look for if you ever watch season 4 again. It's there. But like I alluded to earlier with the thing about Pythia being a Cylon, it was originally a big reveal, and then it kind of ended up being, it's there for you to see, but you have to actually put in the thought to make that connection, instead of being, you're not explicit about it anymore. There's a lot of things like that, and that happened with something like this. They wanted Kara has a vision, and she sees the road to Earth, and it passes by a gas planet with rings orbiting a comet, or with a comet nearby. And we know the comet was a misinterpretation of the vision. It was a battle-damaged Cylon base ship that was outgassed, right? What about the rings? What about the gas planet with rings? Because you'll notice the gas planet doesn't have rings when initially you see it, okay? And you see a flash of Kara's vision. You see, she says, I've seen this, I had this vision, and she describes it, you see a flash of it. And you see what looks like a comet, you see the gas planet, and you don't see rings. And she said explicitly it's a gas planet with rings. Well, let's ask, why do you see Saturn's rings? Well, Saturn's rings are made of fairly large chunks of material, and they're fairly close together. So what I did is I just made these random blobs, we'll call these ice particles in Saturn's rings, and I made random light beams come in. And I tried to model faithfully, it doesn't work if you don't do it faithfully, the angle of incidence equals angle of reflection every point it hits the surface of a particle. And what you find is, and again, these are just kind of random, so I followed these around in one case all over the place, it goes back. In general, they all come back out the field of view the same way they went in. After a few minutes. So that's why you see Saturn's rings are big and bright. But it turns out if you have a very rarefied ring, you have small particles widely spaced, what you get is these are in the same position. This field of smaller particles are random size, random orientation, but these beams are in the same spot as in the previous field. What you see is, generally speaking, they bounce a few times, but they generally pass through the field of view. So you don't see these on this side when the sun's behind you. You see it over here. But since it's not very much gets straight through, it's faint. Turns out that one of our most famous images of Saturn is this one. It occurred on Rev Orbit 28, the nominal mission. And it turned out that and kind of part of like my software determined that we were going to get this image 3 years before we even got to Saturn. But we passed behind Saturn, the sun was behind Saturn, and we're in Saturn's shadow, so you can see a hint of these rings, but you see these really faint rings that you can't see in the visible light unless the sun is blocked out. So they have these very faint rings that you see only with certain geometry. This is called the E-ring, by the way. The cool thing about this image, by the way, and there's no way in hell you're ever going to see this, is that we didn't realize when we first planned this image, is that if you look in the rings very carefully, if you blew this up big time, you actually see a little blue dot, a pale blue dot, if you will. You can actually see Earth through the rings of Saturn in this image. And that's why it ended up on the cover of December 2006 National Geographic. But using that effect, that the fact that you can see some rings sometimes and not other times, you'll see this is actually written into the script. Leoben, the unstruck music vibrates in all of us, but few ever hear it. Kara is one of the few. And then it says, as Athena tries to absorb that, they continue to diverse the debris scattered skies, and the planet occults the 3 stars. Oh, actually, it was also in a trinary system, too. Remember that. When it obscures the final star, the backlit suddenly reveals a diaphanous ring system around the planet, just as Saturn's unseen ring system appeared when Cassini made the same move. So, we want to find this. Recall that this is a grab. This is the screen capture of when Kara had her vision. You see the gas planet. There's the comet, which we now know is a sub-8 star. There's 2 of the 3 suns. There's a third. I'll tell you right now, the trinary system, that was me fracking with the audience. It's knowing that some people are really anal, okay, and knowing that our closest star, Alpha Centauri, is a trinary star system. So I made it a trinary system so people would go, it's Alpha Centauri, they're getting close to Earth, I just know it. No, I'm screwing with you. That was on purpose, by the way. So Kara is painting it on Demetrius, and she was kind of freaking out. So she paints it, and you see Element the star, you see the comet, which actually looks a lot like the Ship of Light from the original series. I don't know if that's on purpose. And that's it. And then we go on, and later, in the road less traveled, when Leoben's finally on board the ship, you see her painting again, and you see that the last star is occulted, and you see a ring system in her painting. So there is looks like one thing from one direction and one thing from another direction. But that is actually in there in her paintings. You can see the rings, but like I've alluded to previously, certain plot elements will gain and lose in importance as a script matures. And this is something that was supposed to be a big reveal that went kind of down to, yeah, it's there, but it went more for a character story, which is important, instead of this big reveal. All right, so wrote the book, The Signs of Battlestar, and while I was writing this, Caprica was just starting up. And Jane Espenson, who'd been a writer for the show and who wrote the intro to the book, was the showrunner for the first half of Caprica. And I said, hey, look, Jane, the first document I ever did for Battlestar, way back when, was surmising what the 12-colony system might be like. Now, the Bible says the 12 colonies are in one star system. No way, no how are 12 habitable planets orbiting one star, but a star system can be a multiple star system. So I said, hey, it's probably in either very closely packed stars at the edge of a cluster, or it's in a multiple star system. If you give me a group of 4, I could get you 12 planets along 4 stars. It's kind of a stretch, but it's things that actually do happen. And she said, okay, well, what do you got? And so what I did is I modified that document, and I took that document that I wrote now, by this time 4 years prior, and said, okay, what can we do here? So it turns out that there is a star system that's popular among astronomers, amateur astronomers, called Eta Lyrae. It's in the summer, and it is a double-double system. It is a binary star system and another binary star system in mutual orbit. So you have 4 stars. I can do something with that. So it turns out that what I did is I wrote a chapter in The Signs of Battlestar saying that what it could be, and then that was like the N-1st, the second to last version. The last version I gave to Jane, and we patterned the 12 colonies after that. And so that actually became the map of the 12 colonies. Have you ever seen that poster? That became that poster. Because quantum mechanics said, hey, we heard it's a quadruple star system, and we think that'd be a really good poster. And it is a really cool poster. So this is basically what they came up with. And there was some iteration with myself and with Jane. Jane's actually initial question was, when I mentioned this multiple star system, he said, well, if we're on Caprica and we have a binary pair at nighttime, is that going to be like, is that going to be too bright? Is it going to like ruin our shot? Which is a valid point. And I said, it's far dimmer than the light you're going to use to shoot the shot. Okay, score, all right. But what we did is we took four stars, and 4 stars of a certain type, what were called K stars, and laid out the planets accordingly. I'm not going into great details. I'm taking time for questions. Turns out, by the way, though, that these are all like in the K range. They're all down here. There's a very narrow range in which planet stars can have planets that support life. Too big, they die quickly. Too small, and there's a whole host of other issues. So these are all like K-type stars, which are smaller, a little cooler, a little orangier than ours. Actually, they're K's and G's. Caprica orbits a star like ours. Why are you keeping forever? Oh, this is actually, I don't know if you can see this. This is Ada Lyrae right here. There's 2 stars here, 2 stars here. This is the system we patterned it after. But there's actually science behind all these planets too. Troy, the mining colony where Boomer had supposedly grown up, was a Mercury-like planet. We included a lot of stuff. There's gas planets, there's fun stuff. And here's the astronomy of BSG in the real world. When you go to a science conference, there are 2 kind of presentations. You have verbal or oral presentations, and you have poster sessions. So I had done a poster session at what's called the DPS. It's the American Astronomical Society.